Hey everyone. So, that's not deaf for myself, so I haven't got 8 million things going on at once. Yeah, how we doing? Where are we at? So we've got some of the we completed so far. So I did this networking one last night, not on stream, but it wasn't that difficult. I might redo some of these ones that I did off stream just so I've got them. There's like a package on the highlights. Same for the Windows fundamentals. I didn't do that on stream either, so you can revisit some of those. But for now, yeah, we've only got 14 free info ones to go. So just going to kick off with the first one: Intro to LAN. This lab will take you through the flaws in different network topologies. A ring topology, all devices are connected to others to create a full circle. Packets of data travel from one device to the next until they have reached their destination. One major flaw with the ring topology is that if a device goes down or a cable is broken, data will no longer be passed. If you hover over the middle of a cable, you can cut it and see what happens. Aha! Slice. The packets can now no longer travel around the network and no devices can talk to each other. Bus topology. With bus topologies, all devices are connected to a single cable, often called the backbone. Data is sent both left and right directions down the backbone until the packet's destination is reached. Major flaw in the bus is that it can't handle a large amount of data. On the next step, send as many packets as quickly as you can and try and take them down the network. So 1, 2, 2. Pow!
Luca says.
Party Popper.
Hey Luca, how are you doing? What if we do it to like 4? This is just going to be triggering all of the packet collision, isn't it? Die! Does this actually break? What's the one? 5. What's that one? Yeah, there we go. Bus network is down. With the star topology, all devices are connected to their own cable to a central switch or hub. Every packet is sent through the switch, which means the switch goes down, the network will no longer work. See if you can somehow break the switch with a hammer. Pow! The network is now down. You found the topology flaws. Right. I didn't actually read any of this. What's the... Where do I put that in? To complete the interactive, so let's just finish that. So what does the lab or the walkthrough talk about? Star topologies, which aren't really used. Oh yeah, these are used. This is like the default now, like everything uses this. Bus uses coaxial cable, which again isn't really used now. Ring networks, yeah, again you probably won't ever see those nowadays. I do love how like you always have to learn about this stuff, even though it's like ancient. Like I've never seen this in every job I've done, and I've worked in like networking roles. Like you just don't see this anymore, unless you're ripping it out and putting Ethernet in. what is a switch? Switches are dedicated devices within a network that are designed to aggregate multiple other devices, such as computers, printers, any other networking-capable device using Ethernet. These various devices plug into a switch's port. Switches are usually found in larger networks, such as businesses, schools, similar-sized networks. Where there are many devices to connect to the network, switches can connect a large number of devices by having ports 4, 8, 16, 24, 32, 64 for devices to plug into. Switches are much more efficient than their lesser counterpart, hubs. Repeaters. Switches keep track of what devices are connected to and which port. In this way, when they receive a packet, instead of repeating that packet to every port like a hub would, it just sends it to the intended target, thus reducing traffic. And then both switches and routers can be connected to one another. The ability to do this increases the redundancy, the reliability of the network by adding multiple paths for data to take. If one path goes down, the other can be used. While this may reduce the overall performance of a network because packets have to take longer to travel, there is no downtime, which is a small price to pay considering the alternative. It's a router's job to connect networks to other networks, which is not mentioned there, and pass data between them. It does this by using routing, hence the name router. Routing is the label given to the process of data traveling across networks. Routing involves creating a path between networks so that this data can be successfully delivered. Routing is useful when devices are connected by many paths, such as the example below. So, let's try and answer it. So, what is the verb given that routers perform? Routing. Yeah. What device is used to centrally connect multiple devices on the network? Switch. What topology is cost efficient to set up? Bus, I guess. Bus topology. Again, you won't ever see it, but sure. What is expensive to set up and maintain? Star topology. And again, that's the only one you'll ever see nowadays. I don't know if Luca's got any insight into that. Have you seen anything other than Ethernet networks? I genuinely haven't. But the closest thing I've got to something that isn't Ethernet would be like PTSN, like phone line cabling, but that's a different thing altogether. Primer on subnetting. As we previously discussed through the module so far, networks can be found in all shapes and sizes, ranging from small to large. Subnetting is the term given to splitting up a network into smaller, miniature networks within itself. Think of it as slicing up a cake for your friends. There's only a certain amount of cake to go around, but everyone wants a piece. Subnetting is you deciding who gets what slice and reserving such slices of the metaphorical cake. Take a business, for example, you have different departments such as accounting, finance, human resources. So this is the physical network, and then these are logical separations of that network.
Cherry's been rumors that the THM Deutsches Forschungsnetz is still using token rings for connecting some universities, but I am not sure how up to date that info is.
Yeah, I mean, my uni used Ethernet. I've never ever seen it out in the wild, so that's why I've just, I've done IT for like 15 years, and I've never ever witnessed the old stuff that I did in my Network Plus exam. So I learnt about it, but I've never physically seen the stuff. While you know there is where to send the information in real life to the correct department, networks need to know this as well. Network administrators use subnetting to categorize and assign specific parts of a network to reflect this. Subnetting is achieved by splitting up the number of hosts that can fit within the network, represented by a number called a subnet mask. Let's refer back to our diagram from the first room in the module. Okay, we can recall the IP address is made up of 4 sections called octets. The same goes for the subnet mask, which is also represented as a number of 4 bytes. ranging from 0 to 255. Subnets use IP addresses in 3 different ways to identify the network address, the host address, and the default gateway. Let's split these 3 up to understand their purposes into the table below. So, network addresses identify the start of actual networks and is used to identify the network's existence. For example, when the device of the IP address is 192.168.1.100, it will be on a network identified as 192.168.1.0. A host address is an IP address here used to identify a device on the subnet. For example, a device will have the network address of 192.168.1.1. It doesn't really explain why that is, but it's because it's the first host on that network. The first number available is 1. And then they give an example. So this final number can be anything from 1 to 254, with 255 being the broadcast. Default gateway. The default gateway is the address of a special address assigned to a device on the network that is capable of sending information to another network. Any data that needs to go to a device that isn't on the same network, i.e. isn't on 192.168.1.0, will be sent to the device. These devices can use any host address, but usually either the first or last host address is in the network. Yeah, so either the first one, which it used in that example for some reason, and then that's the last one, which I said earlier. Now, in a small network such as a home, you will be one subnet, as there is unlikely chance that you need more than 245 devices connected at one time. That's probably scheduled to change.
Limiting your search to the internet as the only means of information exchange. All of the others are in use OFC, the I2C being a prime example.
Not limiting your search to the internet as the only means. So what's the I2C? I've not heard of that. Integrated circuit. Serial bus. That's something to add to my research. Serial protocol decoding. So is it just serial over Ethernet, effectively, like? Okay, alright, I'll read more of that later. Take. Where was I? How am I going places? Yeah, however, in places such as businesses and offices, you will have much more of these devices, PCs, printers, cameras, sensors, where subnetting will take place. Subnetting provides a range of benefits including efficiency, security, full control. We'll come on to explore exactly how subnetting provides these benefits at a later date. However, for now, all we need to do is understand the security element to it. Let's take the typical cafe on the street. This cafe will have 2 networks. It's when you see like massive corporations and they don't even have like more than 1 network. That makes me laugh. This is an example, like a cafe. Oh, this cafe has 2, but like a gigantic networking service will only have 1 globally. So this has 2 networks, one for employees, cash registers, and the other devices for the facility. and it has another one for the general public to use as a hotspot. Subnetting allows you to separate the two use cases from each other whilst having the benefits of a connection to a larger network such as the internet. What is the technical term for dividing into subnetting? Subnetting. How many bits?
It uses its own frame format.
Oh, cool. So it's like a completely separate standard. Has it got an RFC? This is quite cool. Alright, how many bits are in a subnet mask? 32. What is the range of a section octet of a subnet mask? What? Oh, okay, yeah, 0 to 255. What address is used to identify the start of the network? That is... Well, what format do they want the answer in? Oh, yeah, I just want that, I guess. Yeah. What address is used to identify network devices within a network? So this is the host address. What is the name used to identify the device responsible for sending data to another network? That is the default gateway. Cool. Alright. Arp.
Lucas says.
And then there is this entire topic of wireless communication where all client devices essentially share the same wire or better the same medium, which is space, D.
Oh, I love wireless.
Thank you for the follow.
Ooh, thank you for the follow. Where is it? Might put it away. I've got like a filthy antenna somewhere for doing wireless stuff. Yeah, I must have hid it in my box. I've also got some like car hacking stuff to tinker with at some point. I've got my prox mark in here somewhere. Right.
So star topology isn't really applicable.
Yeah, just the air. Is it?
Oh, nice hotspot. Always wanted to get one, never did.
Yeah, I got. Well, admittedly, mine's a Chinese knockoff, but I mean, it does exactly what it's supposed to do. Yeah, that boy. So yeah, get the. Which one's that? So the square one's high frequency, and then you got low frequency, and it'll do like pretty much every badge. And I've put Iceman's framework on there. Yeah, I cloned like some badges and stuff. It's quite easy. Yeah, I need to get some more usage of that. Right, so what we did in Arp Recalling from our previous task that devices can have two identifiers, a MAC address and IP address. That's the physical and the logical. Arp Protocol, or Address Resolution Protocol for short, is the technology that is responsible for allowing devices to identify themselves on a network. Simply, the Arp Protocol allows a device to associate its MAC address with an IP address on the network. Each device on the network will keep a log of the MAC addresses associated with other devices. When devices wish to communicate with another, they will send a broadcast to the entire network, searching for a specific device. Devices can use the Arp protocol to find the MAC address and therefore the physical identifier of a device for communication. How does Arp work? Each device within the network has a ledger to store the information on, called a cache. In the context of the Arp protocol, this cache stores identifiers of other devices on the network. In order to map those different identifiers together, IP address and MAC address, the Arp protocol sends two types of messages, an Arp request and an Arp reply. When an Arp request is sent, the message is broadcasted to every other device found on the network by the device, asking whether or not the device's MAC address matches the requested IP address. If the device does not have the requested IP address, an Arp reply, if it does have the requested IP, then the Arp replies saying that it's returned to the initial device to acknowledge this. The initial device will now remember this and store it within the cache, an Arp entry. This process is illustrated in the diagram below. So it says, who has IP.10, goes to all the devices, and then, what is that supposed to be? Okay. Print a scanner, I guess. It just pings back saying, yeah, I have this IP. So, what does ARP stand for? Yeah, this is what we said on Theo's stream. Like, any of these machines can reply back and say that they've got that IP. And then your machine puts that in its cache. So when it tries to contact .10, it will say, oh, I know .10 is this machine, when it's not. Right. ARP. Address. Yeah. I can't remember the bloody ARN address. Resolution? Yeah, cool. What address of ARP packet has asked device whether or not it has a specified IP address? What category of ARP packet asks a device? Is that just request? Some of these questions are really dumb. What address is used for the physical identifier for the device on the network? MAC address. What address is used as a logical identifier? IP address. I literally said that at the beginning. Right, we're flying through this. DHCP protocol. The IP addresses can be assigned either manually, by entering them physically into the device, or automatically, and most commonly by using DHCP, Dynamic Host Configuration Protocol Server. When the device connects to the network, if it has not already been manually assigned an IP address, it sends out a request, a DHCP discover, to see if any DHCP servers are on the network. The DHCP server then replies back with an IP address the device can use, a DHCP offer. The device then sends a reply confirming it wants the offered IP address, a DHCP request, and then lastly the DHCP server sends a reply acknowledging this has been completed and the device can start using the IP address, a DHCP ACK. Ad break. Sorry. Sorry about the ads. Right, so we've got an example. So your machine, first part on the network, sends. It doesn't have an IP, so it says, "Hey DHCP, can I have an IP address?" It says, "Hey, yeah, I've got this IP address free." It says, "Brilliant, I'd love to use it." And then it goes, "Okay, great, that's yours." And it's got it for 24 hours. Not acceptable. I can't remember what that is. What's the redemption on that? Keep it family friendly. Okay, alright, no swears. What type of DHCP packet is used by a device to retrieve an IP address? So DHCP. It's not a request, is it? It's a discovery.
Lucas says.
Not that I care about the redemption, just wanted to say that the ad was not acceptable. D.
Yeah, I tried to make them all HTTP codes. So for the most part, they do map up with what the code is. And I had to come up with some relevant thing to make that. Yeah, like some of the default Twitch ones, like no swearing and stuff like that. I just made that a 406. What type of DHCP packet does a device send once it's been offered an IP address by the server? DHCP request. Doesn't help having it right there either. Like, that's just cheating. Finally, what is the last packet? Oh, I wonder which one it is. I said this on Theo's stream. Like, if you're answering these, it's good to have that hidden, because I mean, it's also good to go up and check if you don't know. But if you're trying to do it without help, it doesn't help having it on the screen. Continually learning doing the OSI model room. I think I've already done that one. Oh, it's a subscription room. Why is it a subscription room? Right, well that was fairly easy. Let's see what's next. Search. Free. Info. Hide complete. Let's do... I want to do the burp ones together, so I'll skip those for now. Let's do common attacks.